Okay, great. Today we're going to be doing coordinate geometry. Last week, as most of you know who were here, we did regular geometry. Now, geometry itself is a huge chapter. We'll probably revisit that soon. I mean, there's so much stuff we can talk about there. And the nice thing about coordinate geometry is parts of it does relate back to some of the things that we did in geometry itself, because there are shapes that are used in the plane, and we'll talk about that. But one of the great things that I really like about coordinate geometry that a lot of people end up kind of missing is the fact that coordinate geometry really is a vehicle for algebra. Now, as you know, we have this thing called the general equation of a line, or the standard equation of a line, where we say x plus b, and the reality is, like, that in itself is an equation, and as we all know, where there's equations, there's algebra. So, of course, y stands for the y-coordinate, m being the slope, x being the x-coordinate, and b being the y-intercept. So, the first part of today, I want to talk about how they can kind of strategically test you on these things. Sometimes it's really easy, sometimes it's really hard. So we'll kind of work our way up in the questions we're doing, but I do feel confident that by the end of today, everyone should be looking at coordinate geometry kind of in an algebraic sense, which I think is a really cool way to think about these things. So, first question I'm going to put up for all of you who have been here before, and you know, answer the question, put your answer in the chat box, we'll go through the solution, and of course we'll do more. So, first question is this here. Remember, everyone, just make sure you're muted. I think when you get accepted into the meeting, you're unmuted, so maybe something you have to manually do on your end. Okay, so that's about 2 minutes, and I presume that that wasn't all that bad for everyone. So the interesting thing about this question here is they're giving us a coordinate set of coordinates where we have v being the x-coordinate, 4 being the y-coordinate. So in essence, what they're doing here is they're testing us on our ability to know that v can replace the x and that 4 can replace the y. So we have 4 equals 3/4 v plus 8, and we're just going to do the math. We bring the 8 over to the left. That becomes minus 4 equals 3/4 v minus, not sure how that happened. Hold on, I'm just getting the board back. Okay, minus 4 equals 3/4 v. We bring the 4 over, negative 16 equals 3v, divide both sides, and that's our answer. So this is a very kind of basic version of what I'm about to show you, which is a question where we have more plugging, but certainly we're dealing with algebra, you know, in the same kind of sense here. So I want to give everyone a few minutes to try this question here. And in a question like this, it's interesting. I do this with students a lot. There's definitely multiple ways to get an answer with this particular question that I just put up. But I'm going to show you kind of my way of doing it. And as I said in the past, it's okay if you're doing things in a slightly different manner, but this here should trigger the thought of doing algebra. So again, 2 minutes, and then we'll talk about this question. Okay, those are about 2 minutes there. So hopefully as everyone was looking at this question, they've started to use similar processes that we just used in the last question, just with kind of more elements. So when I say more elements, what I mean is the fact that we have 2 sets of points. We have a CD and then a C plus 3 and a D plus K. where C represents the X point, the X coordinate, D represents the Y, C plus 3dx, and D plus K the Y. So effectively what we're doing here is we're creating two equations with our C's, our D's, and our K. So the first equation is simply going to be C equals 3D minus 7. The second equation is going to be C plus 3 equals 3 times D plus K minus 7. So if we focus in on the right side equation, we get C plus 3 equals 3D plus 3K minus 7. We bring the 3 over and we say C equals 3D plus 3K minus 10. Now, what's interesting here is that they're both equal to C, so we can then take them and set them equal to each other. 3D minus 7 equals 3D plus 3K minus 10. 3D's cancel. We have minus 7 equals 3K minus 10. We bring the 10 over. That gives us 3 equals 3K. So, of course, K is equal to 1. Answer choice D. So I want everyone to take a good look at this and understand that this is a very important component of coordinate geometry. I think one of the things we tend to do when we see coordinate geometry questions is we really default to thinking about this in a way where we're not using algebra. As I told you before, there are multiple ways to deal with this question. Yes, using the slope formula is one, but my kind of way I think about the GMAT and these exams is that you want to be extremely systematic in your process. And for me, if I can set up the line equation and do that, I would do that 1,000 times over rather than any other way to deal with this question. Not to say you can't do other things, and it's not to say that, certain things don't feel more comfortable for you, but this is a surefire way that you can definitely get this question right. So now I want to get into something that's, slightly different. We're dealing with when you can tell that two of the same points or 2 points fall on the same line. And when you have the equation of a line, you always have the opportunity to do that. So we're going to do a couple questions. It is similar to what we just did, which you'll see in a second, but it is testing a slightly different component of coordinate geometry. So I'll give everyone a few minutes, and we can kind of discuss this question here. Okay, so this is a question, as I said, is testing on do you know how to be able to tell when you can tell if a point is on a particular line. So what we're provided with here right off the bat is the equation of a line. Now, something, again, that I like to do, it's not something you have to do, but something I like to do is to get this into the standard form of the line equation. So the way to do that, well, first of all, I want to set it up so the y and the x are on the left, is I want to isolate the y. So the first thing is I bring the x over. Point of doing that is to get one step closer to isolating y. So we have a minus x plus 12. Finally, if we divide by 3, we get y equals negative 1/3 x plus 4. So the process in a question like this is to then plug in and determine which points will not fall on the line, which means there's going to be one point which will fall on the line. So we can kind of go through our different answer choices and see which one actually does not. So what we have initially here with answer choice A is we have 3, 3. So y is 3, so put an A here. Then we have negative 1/3 times 3 plus 4. Well, if we do that math in our head, we will see that the equivalent of that will be 3. So that's out. We go to B. We see that our y value is going to be 2. X value is 6. Doing some more mental math, we see that negative 1/3 times 6 is a negative 2. Combine that with 4, we get 2 is equivalent to 2. So that's out. Doing answer choice C, we have the y value being 0. So is 0 equal to negative 1/3 times 12 plus 4. We see that that ends up being 0, so 0 does equal 0. So now the answer is going to have to be D or E. The y value, we have negative 2 is equal to negative 1/3 times 18 plus 4. So that gives us negative 2 equals negative 2. So really, we have the answer being E. Now, could we have started with E and moved backwards? I've heard different things about that. The answer is yes. So, you know, I would let anyone kind of as they decide they want to do that, and you can do that. And can you leave the equation as it is? Yes. You don't necessarily have to make the standard form of the equation. This is again about being systematic and doing the same thing every time. Just to prove that the third equation is good, we have negative 3 being the y. We have a 24 times negative 1/3 plus 4. Does negative 3 equal negative 8 plus 4? Does negative 3 equal a negative 4? No, it absolutely does not. So the correct answer is E. So next, I want to do this same idea, but not with real numbers. And this is going to make this idea a little bit harder, but as you'll see, it's not that bad if you stick to your principles and do the same things over and over. So everyone, 2 minutes, and then we'll talk about this. Okay, this is similar to the last question. We are given that point UV as a point on the line with the general equation y equals mx plus b. So v goes in for y, u goes in for x, and we're trying to determine which of the following must be true. So the first thing is this is really about manipulation, right? So if we were to try to make this match Roman numeral 1, it has to match it for it to be true. So if we were to isolate B, we would say B equals V minus MU. Now, if you look very closely, that's actually opposite the right-hand side of what you see in Roman numeral 1, which is MU minus V. So that's not something that must be true. Roman numeral 2, we get 4V equals 4MU plus 4B. So as you'll see, we have a 4 across the board on each term. You divide by 4. You get V equals MU plus B. Now, if we go to our original equation, we see that that matches directly. So anything with a 2 in it is a good answer. So now it's just a matter of, okay, is it going to be 2 and 3 or just 2? So the last thing we have is b squared equals v squared minus 2vmu plus m squared u squared. So what I would do here is I would get the b isolated from our original equation, which is this. And actually, did I just lie there? No, that is our original equation. So we would have b equals mu minus v. Or excuse me, v minus mu. Almost got that wrong. That would have been bad. And what we're going to do is we're going to square both sides like this, and we're going to see if they match up. Now, what we're doing essentially is a FOIL, where we have b squared equals v squared minus 2 VMU plus m squared u squared, and what you find is it does equal it. Now, if anyone's wondering how I did that so quickly, don't forget that x minus y all squared, which is a quadratic identity, which we have a lot of in chapter 2, is x squared minus 2xy plus y squared. So I did that kind of in my head. Notice the v squared is the x, the m squared u squared is the y squared, and the minus 2vmu is the same thing as 2xy. Now, I would say this is definitely on the upper echelon of difficulty of questions, just because of kind of the, the less straightforward nature of what's happening. The last question, as you can see, although similar, you were working with real numbers, so nothing was all that challenging. And as people had mentioned, there were many different ways people were able to get through that question. So all in all, I think that's a very good question, something that I think everyone should be able to handle. And if you cannot, then, obviously this is something you want to work on. One quick thing I do want to do, I imagine this won't be too bad for anyone, but I do want to talk about actually developing your own equation of a line. And I want to do that here with this next question. And give everyone 2 minutes, and I want to start to talk about shapes in the coordinate plane. Okay, so that was about 2 minutes. This question is nice and, cut and dry, black and white. It's about, can you take a number of points and set up a equation of a line? And this is interesting to see too, because it goes to show that if you have 2 points, you can set up an equation of a line. So for other types of questions that can be asked, these are good things to know, what you need or don't need to set up the equation of a line. So you can start at any place you want. Logically, it would make sense to do the slope. So remember, the equation of the line is y equals mx plus b. So if we start off with the slope formula is change in y over change in x, delta y over delta x. We see that the y, one of the y terms is -1, so we can say -1 minus 3. Then one of the x terms is 1, so 1 minus 3. So be careful with your signs. We get a -4 on the top, a -2 on the bottom, which nets out to be a +2. So if you're running low on time, you could, for all intents and purposes, get rid of A, C, and E because you know the slope is 2. So now what you do is you set up your equation, y equals 2x plus b, where b is the y-intercept, as we've said. Then you take any set of points, you plug it in. I'm going to go with 3 and 3. 3 equals 2 times 3 plus b. 3 equals 6 plus b. -3 equals b. So if the y-intercept is -3, the equation of the line is y equals 2x minus 3. So I do hope that anyone taking the test sees something like that. It would be great because this is one of those things where you know how to do it, you plug in, you get your line, you move on. And to me, that's one of the better ways to be able to deal with questions on the test because it allows us to be incredibly systematic. I want to do one last question. This is definitely going to be as hard as what we've done today. It's in a very challenging nature, test us on shapes in the coordinate plane. So we'll give everyone a couple minutes, then we'll spend the necessary time on this. All right, well, since we don't have a ton of time, we will begin kind of sketching this out. Now remember, it's possible that you'll have, the use of graphing paper and stuff like that, graphing lines, which is definitely something that'll help as you do a problem like this. So I'm going to make kind of my own graph-like thing here, my x and y axis rather. So there's your 0, here's your x and your y axis. So we have a point 0, 10. So 0, move up 10. So we're going to just kind of ballpark this. This over here. Then we have 10, 0. Remember, this is not done to scale, so don't think it is. And then 14, 4. So we'll say that's roughly here. Now, what everyone's going to notice is that this is an awkward shape. Now, if you've read our geometry chapter, we teach about how to potentially deal with awkward shapes. But in this particular instance, there's no way, no how that we are going to be able to get the perimeter of this by just looking at the lines. And if they ask for area, this is another thing that you would be able to do for it. But strategically, what's really cool here is we can actually create a bunch of right triangles from making really a rectangle around this triangle, pointing all the points. And I'll put little right triangle signs so you can see the right triangles. So what we're going to do is we're basically going to use the Pythagorean theorem here to come up with the size of each one of these triangles. So for instance, let's start with something easy. We have a 10, we have a 10. Okay, well the Pythagorean theorem says that 10 squared plus 10 squared equals c squared. So basically, c squared equals 200. C is the square root of 200, which as we know is 10 root 2. So anything with a root 2 in it, you can pretty much already say that's going to be a possible answer, eliminating A and B. Now we can go over to the smaller triangle here, and we can say, all right, well, we know that this line has to be 4 because we're going from 10 to 14. And we know actually that this line has to be 4 because this point here on the far right is 14, 4. So if we do strategic Pythagorean theorem again, we're going to get c squared equals 32 because remember we're talking about 4 squared plus 4 squared. So 16 plus 16 is 32. Square root everything, and we end up with c being 4 root 2. So if we add these together, we see that part of our perimeter is already 14 root 2. So we can now, well actually we can't eliminate anything unfortunately. So now we go to the last component and we see that the big triangle, this has a height of, well it's going from 4 up to 10, so the height of that is 6. And again, remember I told you it wasn't drawn to scale. And this here is going to be 10. So we have 10 squared plus 6 squared equals c squared. So we have c. Let me just make sure that's right. You know what? I made a small mistake there. That's not 10. That's 14. So we have c squared equals 14 squared plus 6 squared. So yeah, this number is getting a little large. I get that. 14 times 14 is 196. Of course, 6 squared is 36. So if we add these together, we get c squared equals 232. So strategically at this point, you can actually finish this question without completing out this to the bitter end, because what we know is we're looking for this final value here. And I can tell you that since we already have 14 root 2, it's about what's the final value in the answer choice. Well, look, square root of 232 is not the square root of 202. The square root of 232 is not 30. So the only answer that's logical here is 2 root 58. And this is something I want everyone to take into account. Sometimes you don't have to go to the bitter end in your answer choices, so the answer here is D. This is a tough one. I'm glad we ended on this one. You know, like always, hopefully you can take away some things that we did here today and start to use them on your own. As always, you know, I want to thank everyone for coming. If you have any questions or concerns, feel free to reach out to me, Jeff at Target Test Prep. And I look forward to seeing everyone here next week. So talk to everyone soon. Bye.